The 1980s built trucks with one priority: do the job, no matter what. No screens, no software, no fragile electronics, just steel frames, big engines, and parts meant to be repaired, not replaced. These trucks hauled heavier loads, survived brutal abuse, and kept running when modern trucks would shut down with warning lights. Comfort was optional. Durability wasn't. Many are still working today, decades later, outlasting vehicles packed with technology. This is the story of 10 trucks from the 1980s that are still better than today's trucks, proof that tougher sometimes beats smarter. Number 1. Ford LTL 9000. The Ford LTL 9000 is one of the most underrated heavy-duty semi-trucks of the 1980s. Largely forgotten, not because it failed, but because Ford exited the Class 8 truck market altogether. Introduced in the late 1970s and produced into the 1990s, the LTL 9000 was Ford's serious answer to the dominance of Peterbilt, Kenworth, and International in long-haul and regional freight. What set the LTL 9000 apart was how conservatively it was engineered. Ford did not experiment with unproven technology. Instead, it focused on thick steel frame rails, robust crossmembers, and proven mechanical components. These trucks were commonly equipped with Cummins Big Cam NTC engines, Caterpillar 3406, and Detroit Diesel 6V92 engines that are still respected today for their rebuildability and longevity. All of these power plants used mechanical fuel injection, meaning no ECUs, no sensors, and no electronic derate issues that plague modern trucks. The chassis of the LTL 9000 was designed with heavy vocational and long-haul use in mind. Front axles, suspensions, and steering components were overbuilt compared to many competitors. This made the truck heavier, but also far more durable, especially in industries like tanker hauling, bulk freight, and regional heavy loads. Many LTLs comfortably crossed the 1 million mile mark with routine rebuilds, not replacements. Where the LTL 9000 still beats modern trucks is serviceability. Every system, air, fuel, cooling, electrical, was laid out logically and could be diagnosed without a laptop. A roadside mechanic could trace problems visually and fix them with standard tools. Modern trucks, by contrast, often shut down or derate due to sensor failures even when mechanically sound. The LTL 9000 disappeared only because Ford sold its heavy truck division to Freightliner in the late 1990s. The trucks themselves did not fail the market. Today, surviving examples are prized by collectors and owner-operators who understand that these trucks were built for decades of work, not short lease cycles. Number 2. International Paystar 5000. The International Paystar 5000 was never meant to be pretty, aerodynamic, or comfortable. It was engineered for severe service, oil fields, logging roads, mining operations, and construction sites where normal highway trucks simply didn't survive. In the 1980s, this made the Paystar one of the toughest vocational semi-trucks on the market. International built the Paystar with extremely heavy frame rails, often thicker than those used on long-haul trucks. These frames were designed to handle torsional stress from uneven terrain, heavy loads, and constant abuse. Unlike modern trucks that rely on electronic traction control and torque management, the Paystar relied on raw mechanical strength. Power typically came from Cummins NTC Big Cam engines, Caterpillar 3406, or International's own large displacement diesels, all of which were fully mechanical. These engines produced massive low RPM torque, ideal for pulling heavy loads out of mud, sand, or steep grades. The absence of electronics meant the engine delivered full power at all times, without software-imposed limitations. One of the Paystar's greatest strengths was its simplicity under stress. Modern vocational trucks often suffer from heat buildup caused by emissions equipment and restricted airflow. The Paystar, by contrast, ran cooler, simpler cooling systems with fewer failure points. This allowed it to operate continuously in high-temperature environments where modern trucks would derate or shut down. The Paystar 5000 is still operating today in remote regions around the world. Many were rebuilt multiple times rather than replaced, which was exactly how International intended them to be used. This rebuild-first philosophy is largely gone in modern trucking. where replacement is often cheaper than repair due to electronics and emission systems. The Paystar wasn't replaced because it was obsolete. It disappeared because the trucking industry shifted toward cost-cutting, lighter materials, and electronics. For extreme duty, the Paystar remains mechanically superior to many modern vocational semis. Number 3. GMC General. The GMC General, produced from 1977 to 1987, represents General Motors' final serious effort in the Class 8 semi-truck market. Unlike later attempts by GM to re-enter heavy trucking, the General was a true, full-blooded highway tractor built to compete with the best of its era. The truck was most famously powered by Detroit diesel two-stroke engines, including the 8V71 and 6V92. These engines were loud, smoky, and thirsty, but also famously durable. They could be rebuilt repeatedly, and parts availability remained strong even decades later. Many mechanics still consider Detroit two-strokes among the easiest heavy-duty engines to service. Structurally, the GMC General used a robust steel frame and a straightforward conventional layout. There was nothing experimental or fragile about it. Wiring was minimal. Air systems were simple. Everything was accessible. This made the truck ideal for owner-operators who handled their own maintenance. What truly sets the GMC General apart from modern trucks is its predictability. Failures, when they occurred, were mechanical and visible. There were no electronic shutdowns or sensor-induced limp modes. This allowed drivers to keep moving or perform temporary repairs to reach a service location, something that is often impossible with modern electronically controlled trucks. The GMC General disappeared not because it was inferior, but because GM exited the heavy truck market entirely in the late 1980s. Today, surviving Generals are respected for their toughness and simplicity, and many are still working in regional haul and agricultural service. Number 4. Autocar AT64F. Autocar has long been known for building some of the toughest trucks in America, and the AT64F cabover from the 1980s is a perfect example. At a time when cabovers were often criticized for cramped cabs and poor durability, Autocar took a different approach. Build it like industrial equipment. The AT64F featured a heavy steel cab, not lightweight composites. This added weight, but dramatically improved durability and safety. The cab tilted forward, giving full access to the engine, an enormous advantage for maintenance compared to modern trucks where components are tightly packaged. Power options included Cummins NTC, Detroit diesel, and Caterpillar mechanical engines, all chosen for durability rather than efficiency. These engines could be serviced entirely without electronic diagnostics, making the truck ideal for fleets operating in cities, ports, and tight industrial areas. What made the AT64F superior to modern cabovers was its structural integrity. Modern cabovers focus on weight savings and fuel economy, often at the expense of long-term durability. The AT64F was designed to survive decades of hard service, frequent stop-and-go operation, and constant loading cycles. Autocar trucks were never mass-produced like their competitors. They were built in smaller numbers with an emphasis on quality and longevity. This is why many AT64Fs remained in service long after other cabovers were scrapped. Today, the AT64F stands as one of the last American cabover semis built without compromise. Simple, rebuildable, and brutally strong. Number 5. Diamond Reo Giant. The Diamond Reo Giant is one of the clearest examples of a truck that disappeared not because it was weak, but because it was too expensive to build. Diamond Reo, an American manufacturer with roots going back to the early 1900s, built the Giant series for one purpose: heavy haul and extreme duty applications. By the late 1970s and early 1980s, the Giant had earned a reputation as an almost indestructible semi. The frame rails were exceptionally thick, often heavier than what competitors used on similar rated trucks. Cross members were massive, and the overall chassis stiffness made the truck ideal for lowboy hauling, oil field equipment transport, and oversized loads. Engine options reflected this heavy-duty intent. Buyers commonly specified Cummins NTC big cam engines, Detroit Diesel 8V71 or 8V92, and in some cases Caterpillar power plants. All were fully mechanical, designed to deliver massive torque at low RPMs. These engines were not fuel efficient by modern standards, but they were incredibly tolerant of abuse, poor fuel quality, and long operating hours. What truly separated the Diamond Reo Giant from modern semis was its rebuild philosophy. These trucks were expected to go through multiple engine rebuilds, transmission rebuilds, and axle overhauls without ever replacing the frame or cab. In modern trucking, frames are often considered disposable after a certain service life due to fatigue, corrosion, or integration with electronics. The Giant's frame was often reused for decades. Maintenance accessibility was another major advantage. There were no multiplexed wiring systems, no engine control units, and no emissions after treatment. Failures were mechanical and diagnosable by sight, sound, and basic instruments. For heavy-haul operators working far from dealer networks, this was invaluable. Diamond Reo ultimately went bankrupt in the early 1980s, largely because it could not compete with larger manufacturers on price. The irony is that many Giant trucks outlived the company itself. Even today, surviving examples are still found in specialty hauling roles, proving that the Giant was engineered for longevity, not cost efficiency, a philosophy largely absent in modern truck design. Number 6. Iveco Turbostar. The Iveco Turbostar was one of the most important European semi-trucks of the 1980s, yet it remains largely unknown outside Europe. Introduced in the mid-1980s, the Turbostar was designed for long-distance haulage across Western and Southern Europe, where reliability and fuel economy mattered more than raw horsepower. What made the Turbostar special was its balanced engineering. It used robust, mechanically injected turbo diesel engines that prioritized durability and efficiency. These engines were not pushed to their limits, which allowed them to run for very high mileages without catastrophic failures. Many Turbostars exceeded 1 million kilometers before major overhauls, a significant achievement for the era. Unlike modern European trucks that rely heavily on electronics, the Turbostar's systems were largely mechanical. Fuel delivery, turbocharging, and engine management were straightforward, making diagnostics simple. This was especially important in the 1980s, when cross-border transport often meant limited access to manufacturer-specific service centers. Cab design was another strong point. The Turbostar offered one of the more comfortable sleeper cabs of its time, but without unnecessary complexity. Interior components were durable and designed to withstand constant use. Many surviving Turbostars still have original dashboards and switchgear, something rare in modern trucks after decades of service. Cooling and drivetrain reliability were also notable. The Turbostar was engineered to operate in hot Mediterranean climates as well as colder northern regions. Modern trucks, burdened by emissions heat loads, often struggle in similar conditions without derating. The Turbostar simply kept working. The reason the Turbostar disappeared was not failure, but regulatory evolution. As European emission standards tightened and electronics became mandatory, the Turbostar's purely mechanical design was phased out. Yet many remain in operation today in Eastern Europe, Africa, and parts of Asia, where their simplicity and durability still make them preferable to newer trucks. Number 7. Leyland Roadtrain. The Leyland Roadtrain is one of the most misunderstood semi-trucks of the 1980s. Early production issues damaged its reputation, but later 1980s Roadtrains proved to be durable, efficient, and easy to maintain. The Roadtrain was designed as a lightweight long-haul truck for the UK and European markets. Weight mattered enormously due to strict axle limits, and Leyland engineered the Roadtrain with a lighter chassis than many competitors. Critics initially mistook lightweight for weak, but real-world operation showed otherwise. Engine options evolved through the decade, with later versions benefiting from improved reliability and better cooling. These engines were still largely mechanical, allowing straightforward maintenance without electronic diagnostics. For fleet operators, this meant predictable costs and fewer surprise failures. One of the Roadtrain's biggest strengths was service accessibility. Components were easy to reach, and routine maintenance could be performed quickly. This reduced downtime, a critical factor in long-haul operations. The Roadtrain also excelled in fuel efficiency for its time. Compared to heavier trucks, it consumed less fuel without sacrificing reliability. In an era of volatile fuel prices, this mattered greatly. Many road trains continued working into the late 1990s and early 2000s, long after critics expected them to be scrapped. Their disappearance was tied more to Leyland's corporate struggles than to the truck itself. Today, the road train stands as an example of how practical engineering can outlast early criticism. Number 8. Steyr 19S. The Steyr 19s was built with a very specific environment in mind: the Alps. Austrian manufacturer Steyr designed this truck to handle steep grades, harsh winters, and continuous heavy loads, conditions that expose weaknesses in poorly engineered vehicles. The 19s featured exceptionally robust drivetrains, with engines tuned for torque rather than speed. Mechanical fuel injection ensured consistent performance regardless of temperature, altitude, or fuel quality. In cold conditions where modern trucks often suffer electronic faults, the Steyr simply started and worked. Braking systems were heavily reinforced to handle long downhill runs. Cooling systems were oversized to prevent overheating under sustained load. The chassis was designed to resist twisting on uneven mountain roads, an area where lighter modern trucks often struggle. Steyr's military background influenced the 19S heavily. Many design choices prioritized reliability over comfort or cost. Components were selected for durability and ease of repair, not for weight savings. This philosophy made the 19S popular not only in civilian haulage but also in government and defense roles. The Steyr 19S disappeared as European truck manufacturing consolidated and electronics became unavoidable, but its legacy remains strong. Even today, Steyr trucks from the 1980s are still operating in mountainous and remote regions where mechanical reliability matters more than technology. Number 9. Magirus-Deutz 320D. The Magirus-Deutz 320D stands apart from nearly every other semi-truck ever built for one extraordinary reason: its air-cooled diesel engine. In the 1980s, while almost all heavy trucks depended on large, complex liquid cooling systems, Magirus-Deutz remained committed to air-cooled technology, and for many applications this decision made their trucks more reliable than modern equivalents. The Deutz air-cooled engines used in the 320D eliminated entire systems that commonly fail in modern trucks: radiators, coolant hoses, water pumps, thermostats, and antifreeze. In extreme heat, desert environments, or remote regions, these missing components were a major advantage. There was simply less to go wrong. Overheating due to coolant loss, a common cause of engine failure, was almost impossible. From an engineering standpoint, the engines were designed with large cooling fins, powerful engine-driven fans, and carefully managed airflow. While air-cooled engines were louder and less refined, they were exceptionally tolerant of abuse, poor maintenance, and long operating hours. These engines could run continuously under load in conditions that would force many modern trucks into thermal derate. The chassis of the 320D matched the engine's durability. Frames were heavy, straightforward, and designed for long-term use. The truck relied on fully mechanical fuel injection, meaning no electronic sensors, no ECUs, and no computer-controlled shutdowns. Mechanics could diagnose problems by listening, inspecting, and measuring, skills that are increasingly irrelevant on modern trucks. The Magirus-Deutz 320D was widely used in Africa, the Middle East, and Southern Europe, where extreme temperatures and limited service infrastructure made simplicity critical. Many units remained in service well into the 2000s, long after newer trucks had failed due to cooling or electronic issues. The reason these trucks disappeared was not failure, but regulation. As noise standards, emissions rules, and fuel economy requirements tightened, air-cooled heavy diesels became politically and economically unviable. Yet in pure mechanical terms, the 320D remains one of the most environment-resilient semi-trucks ever built, outperforming modern trucks wherever cooling systems and electronics become liabilities. Number 10. Sisu M-series. The Sisu M-series represents one of the most extreme examples of environment-driven truck engineering. Built in Finland, these semi-trucks were designed to operate reliably in sub-zero temperatures, deep snow, and poor road conditions, environments that routinely disable modern electronically controlled trucks. In the 1980s, Sisu engineers prioritized cold weather reliability above all else. Electrical systems were kept simple and robust. Mechanical fuel injection systems were chosen specifically because they do not suffer from sensor freeze, ECU failure, or software errors. In extreme cold, simplicity equals reliability, and Sisu understood this better than almost any manufacturer. The M-series used heavy frames, reinforced suspension components, and drivetrains designed for constant traction challenges. These trucks were commonly specified with engines from Cummins, Detroit Diesel, and other proven manufacturers, all in mechanical form. These engines could be started, warmed, and operated in temperatures where modern trucks often refuse to start or immediately enter fault mode. One of the defining characteristics of the Sisu M-series was its modular, service-friendly construction. Components were accessible, replaceable, and designed to be repaired in field conditions. This was essential in northern regions where breakdowns could be life-threatening and service centers were far away. Unlike modern trucks that rely on electronic traction control and stability systems, the Sisu depended on weight distribution, gearing, and mechanical grip. This made it predictable and controllable on ice and snow, whereas modern trucks can behave erratically when electronic systems intervene incorrectly. Sisu trucks were never produced in large numbers, and they were never cheap. That limited their global spread. But where they were used, Finland, Scandinavia, Arctic operations, they earned an almost legendary reputation for refusing to quit. The M-series faded as emissions regulations and global consolidation reshaped the truck industry. But even today, older Sisu trucks remain in service in extreme climates, proving that environment-specific mechanical engineering can outperform modern technology when conditions get brutal. So that's it for today. If you like this video, then please hit the like and subscribe button for more videos. Thanks for watching.